Okay, so welcome everybody. My name is Jakub. I came from Poznan. I'm working as a tech lead at Flips company. I'm also the co-founder of this company. We're located in Poznan as well. So maybe that's all about my private life. Let's go straight to the topic. So today I would like to talk about GraphQL servers and how to make them production ready, or at least how to make them more production ready. So I don't have a lot of experience with GraphQL. I joined a project a year ago, and that was the first time that I encountered actually GraphQL. And I would like to share my experiences after 1 year working with that, and to tell you what kind of problems and issues we encounter. Yep, the mic seems to have some problems. Okay, but I'm back. Okay, so GraphQL, as you probably know, you all know the benefits of the GraphQL, what it's supposed to solve, what it's supposed to know. Okay, so first of all, I mark this presentation as not for beginners, so it's not gonna be a very advanced presentation, but I do assume you know a little bit about GraphQL, so basically what GraphQL is, what queries and mutations are, and ideally, if you wrote at least a single GraphQL server in the past. It doesn't have to be in Python, it can be any other language, so I try to keep the presentation, I would say, framework and language agnostic, so you can use that knowledge to any kind of library or programming language you actually use. But examples are going to be written in Python, obviously. So just to remind you, GraphQL was supposed to solve the problem of overfetching and underfetching of the data. Because basically, instead of having a fixed set of endpoints, that's how it is in case of REST web services, we have a single point of entry, and client is responsible for sending us a query with the list of fields they would like to get. So that's why we don't both overfetch or underfetch the data. This is the promise of the GraphQL as a server. And this is at the same time the biggest problem that GraphQL actually introduced. So I have a saying that the total number of problems in a project is constant. You can only shift the burden. What I meant by that is that whenever you hear that the given framework, the given library approach or anything is going to solve all your problems, this is unfortunately usually a lie. So it's going to solve a particular kind of problems, but at the same time, it will most probably introduce another kind of problems in your project. So you have to know what kind of problems it's going to give you so you can address them appropriately. I'm going to use a lot of comparison with a standard REST web services because this is, I would say, a still more popular approach. So we can see what kind of additional things have to be introduced in order to properly maintain a GraphQL server. So let's take a simple example. Let's say that we want to get a book with the ID number 6. So in case of GraphQL, it's going to be like a get query for the path API books/7. That's the most probable way it's going to look like. In case of GraphQL, as I said, there's only a single point of entry. So it's usually going to be like a post to /GraphQL. Okay? So in case of REST, there's going to be no request body because everything is already encoded in the method and the URI. In case of GraphQL, the actual query is embedded in the request body. When it comes to response, the response body, the response payload, is usually actually pretty much the same when it comes to GraphQL and REST. The only thing that differs is that GraphQL obviously requires you to use those envelope and embed the actual response in the data field. But overall, the look of the response is going to be pretty similar. And the status code in both cases is going to be 200 OK. Give me a second. Okay, I heard that somebody took my second literally. Sorry, it was about 6 seconds, I guess. My bad. Okay, so let's go next and see where the real differences are. So what's going to happen when we request a book with the ID that does not exist? So the request is going to look pretty much the same as on the previous slide. The only change here is the ID. Here is also the only change is the ID on the GraphQL side, so instead of 6, it's now 666. And here's the real difference. So in case of REST Web Services, REST Web Service is supposed to return 404 status code when the given entity was not found. In case of GraphQL services, the response is still 200 OK. And the real error is embedded in the response body. So you have to parse it in order to know that there was an error. Okay, so how about updating the existing book with 86? Okay, so in case of REST, we can already see that this is not a query, so this is kind of like a mutation, because instead of the get method, we use the patch method. And the payload in this case looks pretty much similar, because we have to somehow send the updates, the new expected values that we want to have in the given object. And the responses also look pretty much similar. Of course, GraphQL has some extra data on the right, but I would say that there's still like ID name and other stuff. Okay, so how it's going to look in case there's an error in the mutation. So here's when the things are going to get found. So both these roles are still pretty much similar, but the real response, the real difference is in the response. So in case of REST Web Services, we've got 409 conflict error, and in case of GraphQL, as you might have already guessed, it's still 200 OK. So why I was talking about that, the real question you might ask. So when it comes to observability, in case of when we analyze that on the HTTP level, in case of REST Web Services, you already have a lot of information when you take into consideration the HTTP method and the URI. In case of GraphQL, you're going to get post and /GraphQL. So yes, it is a GraphQL request. Thanks for that. In case of body, let's be honest, usually body is not locked by default. And that is because it might contain some sensitive data like tokens, passwords, and other stuff. So usually you don't have access to that, at least out of the box. And when it comes to responses, in case of REST, you have access to the status code. So when you see something like 200, 201, 202, it's okay. If you see something like 400, it's a client-side error. If you see something like 500, that's your mistake. That's a server-side error. In case of GraphQL, everything is like 200 OK. Doesn't mean that GraphQL can't have any errors. Of course it can. And one thing that I forgot to mention, and I should have done that in the beginning of my presentation, sorry about that, and thanks for reminding me. If you were on the previous slides or yesterday, there's a partner, Slido, so you can join the website slido.com, is that correct? Yeah, add hashtag PyConPL, and then you can put your questions there. And room C, of course, because we're in a room C. Thank you. And I'll try to answer the questions as good as I can at the end of the presentation. Okay, so what we just discussed are the differences in observability. So just in case you didn't know that, the abbreviation like O11Y is the abbreviation used for the observability. So the easiest solution to deal with that problem is actually use something that is GraphQL aware. Because if you take a look at the standard access logs, for example from Nginx or any kind of other load balancer, they're not going to be helpful because of the reasons we already discussed. Because you're going to see like the same method and path over and over again, and usually the 200 OK response. So you have to have some dedicated support for interpreting GraphQL queries. And for that, you can use things such as Apollo Studio, Datadog. If your company already uses Datadog, try to use that for GraphQL service as well. Or if you want to go open source, try to integrate that with Grafana and Tempo using the open source standard called OpenTelemetry. So what you can do to additionally add some information, some metadata to your requests, to your GraphQL requests, so you can actually differentiate them. Always use named operations. This is not something that is actually required by the GraphQL, so you don't have to name every operation. But if you don't do that, the operation is going to be considered anonymous. And because of that, you won't be able to easily identify it. So that's how the standard query looks like. So the green type is like operation type. It can be query or mutation. The orange part, that's the part that I'm talking about. This is the optional operation name. So it can be any kind of identifier. So when you write the client-side code, whether it's like a web app or a mobile app, ensure that each request has a separate operation name, so you can easily identify where this request was created, originated from. And of course, the blue part are variables. What else? Remember to set up app names and version. This is not something that is actually purely related to GraphQL, because it's usually a good practice to set user agents when you send REST requests from the mobile app. But in case of GraphQL, this is usually handled slightly different. So when you use Apollo clients, for those who are not familiar with the front-end development, Apollo is like the most popular client, the GraphQL client used in JavaScript and TypeScript environments. So, but this can be also applied to like other kind of clients. So basically what you do, you can add the app name and the version to easily identify what kind of client actually triggered the given request, whether it was your mobile app or your web app, or maybe your, I don't know, some app working on an embedded device or something, and what version it was running on when the request was made. In case you are wondering how these values are sent to the server, on the low level they are included as HTTP headers with those names. So what kind of benefits can you expect when you introduce Apollo Studio to observe, to monitor your GraphQL service? So this is how the standard Apollo Studio dashboard looks like. I'm pretty sure that people at the back of the room are not able to read everything, but basically what you can see here, when you see the highest request rate and the other stuff, it's mentioning operation names. So that's why setting the operation names is so important, so you can actually, let me close the door for you. Okay. So you can identify requests based on the operation name, and that's why it's so important to set it. The other thing that those tools allow you to do is to actually observe how the resolvers work on the level of field resolving. Because GraphQL is so flexible, because the client is actually dictating what kind of fields they want, you have to observe that on the field level rather than the request level. And that's the problem that we're going to go over and over again during this presentation. Because in case of REST web services, you have like a fixed number of endpoints. And you know exactly that, for example, your application is having 30 endpoints, and that's all you can expect. In case of GraphQL, at least in theory, you can expect an infinite number of combinations when it comes to requests sent by your clients. Okay, so something very simple, and again, this is not something that is only true for the GraphQL service. It should be done properly in every kind of a server. Is pagination. So whenever you need to return a big set of data, you should not return everything at once. But there's actually, this thing is quite well covered in GraphQL because there's a great standardization for that. So whenever you need to implement pagination in GraphQL, of course you can do it your way, the way you want it, but I strongly advise you to use so-called relay spec. So this is how the GraphQL query looks when you use the relay spec for the pagination. So as you can see, we've got two additional, is it looking good? Yes, it is. We've got two additional arguments here. The one is named first and the other one is named after. So first is basically like a limit parameter. You're telling how much objects you want to fetch. And after is a cursor. So once you get the first, let's go page, okay? So once you get the first page, you're gonna get the cursor and use this value to ask for more. So this part is called a connection. So in this case, it would be probably named book connection. So each connection has edges and page info. Page info contains information about the given page, whether it has a next page, what's the end cursor of it. The real value, the value that you were actually wanted to get, so in this case books, it's included in the node field. And that's the value that you should actually use when you want to fetch more data. So this is the end cursor that you're supposed to put into the after value. So a few tips about the pagination in GraphQL. As I said, use relay spec, don't try to reinvent the wheel. Cursor value should be considered opaque. What does it mean? It's not supposed to be decoded by the clients, even if it has some data encoded in it. So usually cursors are derived from the type, from the model name or something, and the ID of it. So how you can enforce this opaque behavior? The easiest way to do that, to prevent people from trying to decode that, and this is like a good practice and something that is very common in GraphQL servers, is to use the base 64 of the following combination. So yes, you're right, it can still be decoded, and usually that's the goal of this behavior, but it's supposed to tell the clients that you should use this value as opaque and do not try to decode it. And remember to always set the maximum connection size, so the page size. Again, this is also true for other kind of web servers, not only GraphQL. So don't allow your clients to request a huge amount of data. So yeah, it's nice that you implemented pagination, but somebody requested like 500 items. So yeah, it doesn't really look like a pagination anymore. So keep in mind that always set that limit, set it globally. So for example, you cannot request more than, let's say, 100 items. And keep in mind that you can actually customize that based on the type. So for example, in case of like small things, I don't know, maybe messages, it's meaningful to have a higher limit than in case some other type that is more complicated, more complex, and you know that people won't need to have like a large number of that fetched at once. And of course, if you want to know more and you want to ensure that your implementation is up to the spec, the full specification, it is actually pretty short, so you can read it like from the start to the end within probably 5 minutes or 10, I don't know. It's available on the relay.dev website. And in case you wondered why I'm holding the mic in a very weird way, I know it looks weird. It's a tip from the previous speaker. And if anybody is speaking in this room, this is the only way the mic is actually working. If you're gonna hold it normally, like, you know, like this, it's usually gonna do some weird things. So this is actually tested empirically. Okay, so let's go to something else. So we talked about observability. I gave you some tips about the pagination. So let's talk about the performance issues. N+1 problem. Who's familiar with the term N+1? Awesome. So most of the room. Great. So N+1 problem is usually associated with the ORMs and the fact that this is the way the ORM works under the hood, and you usually introduce N+1 problem unintentionally. Because if you did that intentionally, it wouldn't be a problem, I guess. Okay, so let's take an example. So let's say that. Okay, it's doing weird things in this pose as well. Okay, so let's talk about this example. So for now, let's forget about the pagination for the simplicity. So let's keep it simple. We want to return the following response. So this is basically a list of books. We've got only 3 books. It's a very, very, very small library. And naturally, each book has an author. And as you might imagine, author is a separate table, so it requires a separate call or joining tables. So if we were to implement that as a REST endpoint, for example, in Fast API using SQL Alchemy. I don't know if you use SQL Alchemy, or whether you use Django or RAM, but it's not going to be like rocket science here, so probably you can manage even if you don't have any experience with that. Because basically what you would do, you would select the books and additionally use some kind of like extra method to indicate that you want to prefetch the authors for all of those books. In case of SQL Alchemy, this is done using the options and selected load method. And in case of Django or RAM, that would be, I guess, select related or something like that. And if you do it that way, it's gonna execute only 2 queries. So first one, it's gonna fetch all the books, and the second one is gonna be optimized, and it's gonna fetch all the authors using a single query. If you don't do that, naturally you would make a single query for each book, trying to fetch the author for the given book. Okay, so if we implement our GraphQL server the same way we just did the REST endpoint, that would be just fine for the following query, right? It's going to be very optimized, nice, fast, awesome. But as we discussed before, the GraphQL is more flexible than REST. So it's possible that somebody is going to request only titles of the books because they don't care about the authors. So is it going to work in this case? Of course it will, but there will be some data overfetching. What it means? It means that on the backend side we're going to fetch the authors, but we're not going to actually return them. So it's like wasted resources. And it can also get more complex. So the books can have reviews. So that would mean that we'll have to actually prepare for that and maybe probably do two select in loads in SQL Alchemy to fetch also the reviews. And it's going to be more and more complicated when you think whether somebody asked for reviews or not. Okay, so let's see some code finally. Who's using Strawberry here for implementing GraphQL service? Wow, a single hero.
I have presentation tomorrow about GraphQL.
Awesome. What's your name?
Hey,
Kamil, right? Okay, so Kamil is going to tell about GraphQL servers, how to write them. So if you're not really familiar with GraphQL, visit this guy. Okay, so who's using something else like Graphene, Ariadne, or something? Great, second person. Who's using anything else that I haven't mentioned? Okay, I hope you're able to keep up to the speed of this presentation. Okay, maybe we're going to have some questions, or maybe a lot of questions during the Q&A. I'll try to do my best. Okay, so let's go to the code. So what we declared here in Strawberry. So there's like a top-level query, and a type for book and a type for author, obviously. And we've got some helper methods and the real implementation is not given here to keep it simple. So this from RM method is supposed to convert the SQL Alchemy model to the actual Strawberry type. We've got some Scholar values, very simple ones that are assigned directly, in this case name and title. And we've got some more complex values, objects. So this is the root query books. When we actually fetching the books and basically using the list comprehension, we are converting them to types. To book type, to book GraphQL type. And we've got the same trick for author. And here we've got this Strawberry private. So in case, and you probably haven't used Strawberry because I already asked about that. But Strawberry private is basically like a private variable that you can use when you're writing your resolvers, but this is not going to be exposed in the GraphQL level. So it's only to keep your extra data that you need in the given type. So we're using that to actually be able to fetch the given author. And as you can see, the author resolver is pretty simple. It's using this value, trying to fetch the author from the database and returning it. Okay, so I need to change my hand. Okay, so let's see how it's going to behave when it comes to resolving the following query. So that's the code on the right. And using the root resolver for books, we're going to actually get only the books, like the ID and title, because this is what we fetched from the database. And that's going to naturally execute the following SQL query. Okay, and then it's going to recursively try to resolve each field that was not returned by the root resolver. In this case, it's author. So it's going to take a look at the first author, and it's going to use the resolver for author. It's going to fetch the author and put the data in the response. It's going to do the same thing for the second book, executing another query, and it's going to do the same thing for the last book. This time, okay, what's wrong? Hello, okay. And it's going to execute the last query with a different ID. So if we sum it up, it's going to generate a classic n+1 problem. And this is mostly because each resolver in GraphQL work independently. So there's no implicit connection between those fields. So if you wrote a resolver that's just going to fetch a single author for the given book, and you return 3 books, it's going to be executed 3 times, just as I showed you. Okay, so how to solve that? So people at Facebook realized pretty soon that this is like a natural thing for GraphQL, and they didn't even think that this is something that have to be taught to others. Unfortunately, it has to be, because not everybody is aware that this is the thing as the people were in Facebook. So the solution for that is data loaders. So what is a data loader? This is, I would say, a solution, a pattern that is used to directly solve the problem that we just saw. So let's say that we are actually pretty satisfied with the way resolvers work. I mean, it's pretty nice that, because once again, one thing that is not in the presentation, the slides, why do we want resolvers to work independently? This is because if somebody is not gonna fetch authors, the author resolver is not gonna be called. And if it's not gonna be called, it's not gonna overfetch the data. So we want to have this work as close as possible to the field that is being resolved. So we just have to address the problem with the fact that we are generating implicitly n+1 queries. So the first part of the data loader is actually the loader function, and it's given the list of keys. And given the list of keys, you are supposed to fetch all the items, ideally using a single query, and returning a list of the given models that you resolved based on those keys. You have to somehow initialize this data loader, and the important thing is that it cannot be like global, because data loader has some caching by default. So you have to create a fresh data loader instance for each request. This is usually done by injecting the data loader instance into the so-called GraphQL context. Every kind of framework library has some kind of like context that is usually later available as an info variable. And if you take a look at the actual resolver implementation, it's relatively simple. We're basically using the author loader, the one that we just declared, and we're executing the load. But you have to take a look that there's a wait there and how it works. So there's gonna be some magic here. And for that, we need a sip of water and the next slide. So let's go once again over the code that we just discussed, but how it's going to behave with the data loaders. So the first step is going to be pretty similar. We use the root query to fetch all the books and generate the following SQL query. But what's going to happen when we try to start resolving the authors? So the resolving part is going to look pretty much the same, because we're going to try to resolve the author for the first book. But instead of like executing a SQL query, we're going to queue this operation in the data loader. So, okay, so it just returned, but it's like return a promise. So I'm going to do that, but not right now. So this operation is going to be deferred. Okay, so GraphQL server is satisfied because it got some value. It's like a promise that is going to be available later, but it's something, right? So the same is going to happen for the second author. So it's going to add to the author loader's keys array. And for the last one, it's going to also be added here. So now we've got this keys array, the one that is supposed to be given to the data loader function. And it contains like 1, 1, 2. So we know that we have to somehow fetch those values, but they are not fetched immediately. So once everything is like resolved and we enter the state that it has to take care about those promises, those things are going to be passed to the load authors function that we wrote before. And that's going to generate a single query, because this is actually what is written there. I know it's pretty small right now, but basically we're doing a select in manually based on the values from the array. And once we have it, we're going to return something like this. So as you can see, what's really important in case of the data loaders, the result array has to have the same number of elements as the input array. So in this case, even though we've got like a duplicated ID, we have to also return a duplicated object in the result. So once we have it, those values are sent back to the resolvers. And this is how we manage to somehow overcome the n+1 issue. And this can be executed like recursively. So if, for example, if author has a relationship to some other object, it can also use data loaders, and it can work over and over and over again in the same manner. And keep in mind that data loaders have like an internal cache by default. So if you for some reason manage to fetch the same ID later in the code, like in a nested query, it's not gonna execute any kind of query, it's gonna basically return the value from the cache. Okay, there's also another approach to that problem. Some might say that it's easier to understand because there's going to be no magic there. Usually it's called like a smart root resolver, or some call it, I guess, almighty root resolver, whatever. So this is how it looks like. So using the info parameter that is passed to each resolver, you are able to inspect the query. So without going into more details, because this would be somehow framework related, you are able to get a list of requested fields using this info object. So basically, when we're resolving books, we are able to check whether somebody asked for authors or not. If they do, we can extend the query to do the selected load, and if they don't, we don't have to do that. So that's why we don't do any kind of both overfetching or underfetching. Yeah, I was supposed to move it here so you can follow what I was talking. So this is the info object. It's basically injected as an additional parameter, and it's done automatically by the framework. And that's the real magic when you actually check whether somebody requested the author and conditionally extend the SQL query. And this is the approach that you can find in something like Graphene Django Optimizer. So for those who are using Graphene, there's Graphene and Django. There's a library called Graphene Django, and it's supposed to help you with constructing GraphQL types based on the Django models. So Graphene Django Optimizer is using that folder to actually create optimized queries. And I'm not sure if it's visible for you. Can you tell me whether this is big enough for you in the end of the sun? Okay, awesome. So I've got some reference. So as you can see, there are some posts like GraphQL optimizer.query, and it's using like a ingredients object all. So basically something returning a query set, and it's passing as a second argument this info parameter. So what this library does, it's basically inspecting the info parameter to see what kind of fields were actually requested by the query to do it efficiently. Okay, so we talked about observability, we talked about performance. Let's talk about the things that can go wrong when it comes to GraphQL 7. So, I have to speed it up a little bit because we're kind of over time right now. So there's something about depth limiting. So considering that the client is responsible for sending the query, it's possible that they're going to ask for books, right? And each book has the author, naturally. But when you have a reference to the author, you might ask about the books the given author wrote. And of course, for the given books, you can ask for some reason for the author. And when you've got these authors, you can ask for books again. And when you ask for books, you can ask for authors. And well, I think you got the concept. So basically, there's nothing that can prevent our clients from doing that. So we have to be ready for that. And the solution is actually pretty simple. Most of the frameworks do have, by default, some kind of extension that's actually limiting the depth. So that's like the easiest solution to the problem. So basically, you are not allowing your clients to send queries that are that has more depth than, like, let's say, 10 levels. I would actually suggest something less, but I guess that's the example from the Strawberry docs. Okay, additional thing to take into consideration, because people sometimes are not aware of that even, because people know that they can construct like a very complex queries in GraphQL, but you are also able to send like multiple queries at once using aliases, but you can do the same for mutations. And this is something that can really bite you in the rear. So you can do, for example, something like this. So you can send a single HTTP request and ask the server to execute all three things at once. They are not going to be actually handled in parallel, they are going to be handled sequentially, but still, this is like a single HTTP request. So when you use methods that are typical for REST web services, so for example, you do rate limiting. If you do the rate limiting based on the number of HTTP requests only, you're not going to protect yourself from that. Because if you do the rate limiting based on the HTTP request and you say that you can't execute more than one request per second, you can still overcome that if you send like, why not, 100 mutations in a single query, right? So basically, if you want to rate limit GraphQL server, you need to have something that's going to be GraphQL aware, because everything is encoded within the payload. So looking at the request level is not going to be enough for you. Another thing to consider, and this is actually borrowed from the GitHub, if you want to take a look at a very nice implementation of the GraphQL server in the wild, consider looking at the GitHub API. GitHub has a GraphQL API, and there's also a nice GraphQL Explorer available. So you can basically play with the GraphQL API in the web browser using an embedded client using your account. So this is something that they mention in the overview, in the resource limitation, in the rate limiting section, that you cannot really ask for more than 500k nodes. I would say that this is still a very high number, but this is what they decided to do. And this is also like instruction how to calculate that. So what they meant by node. Node for them is like a single object, a single entity. So when it comes to the examples that I was talking about before, that would be a book and an author, right? In case of GraphQL, a node is a single issue or a single repository. So in case you're using connections, once again, GraphQL relay connections with these edges, nodes, and other stuff, when we discuss the pagination, you have to take into account that you have to actually multiply those values. So we're asking for first 10 issues. So in worst case scenario, that's going to return 10 issues. But we're asking for issues for each of the 50 repositories that we wanted to fetch. So you actually have to multiply the 50 by 10 in order to get the total value. Okay, if you want to do something more complex, to be sure that you are able to protect yourself from very nasty queries, you can implement something that is usually called query cost calculation. So it's very similar to the idea that I discussed based on the GitHub example, but it's doing some more math under the hood. So the simplest implementation would be like that. For each object, let's assign a cost 1, meaning that whenever somebody is going to fetch an object, it's going to cost them 1 value. Whenever they're going to ask about the scalar, what a scalar is. Scalar is like a simple value within the object. So it's like a string, integer, enum, something like that. They're not going to cost them anything. And whenever they call, whenever the client wants to fetch a relay connection, the cost is going to be 2 plus the number of elements they want to fetch. So 2 is like a fixed cost for resolving the connection, the fact that you have to reach the database, do the pagination stuff and other things. And this plus n is supposed to cover the case because the cost of fetching like 2 items is going to be much smaller than fetching 200 items. Okay, so let's go quickly over the example so we can see how the cost can be calculated. I'm going to give you a while to take a look what this query is actually doing. So it's fetching the books with authors and reviews. So this is based on the examples that we were discussing before. So let's start from the middle of that. So this is fetching a review. Test, rating, publish, ad created by, those are scalar values. So we're not going to pay for them. But we're fetching the review nodes, the review type. So that's going to cost us 1 according to the table from the previous slide. Okay, so now let's talk about the reviews connection. Because we're not fetching a single review, we're fetching 3 first reviews. So that's going to be a connection. So connection is going to cost us 2 plus the number of items. So that's why we're using this. And the value 1 is copied from the review. Because we're going to fetch 3 reviews, and each review is going to cost us 1. So 2 plus 1 times 3 is 5. Okay, so let's take a look at the author. So author is also an object, so it's going to cost us how much? 1, great. So it's going to cost us 1, simple as that. Are we going to pay for the title and image and publish ad? No, because those are scalar values, so they're not going to cost us anything. But they are included in the book node. And book node, by definition, is going to cost us 1. But we have to also include all the values that were embedded in the given type. So in this case, we're gonna take the value 5 and the value 1. And now that I'm talking about it, I guess you might think about adding additional 1 for the book node itself. That might be an error on my side. But that's not gonna change a lot our calculation here. Okay, and in the end, we have to resolve the book connections. So once again, because this is a connection, we're gonna assign the value 2 and add to this the number of elements, in this case 5 elements, and multiply that by the cost of those elements. So in this case, it's gonna be 2 plus 5 times 6, where the value 6 is actually fetched from the book node. So in the end, we managed to get the number 32. And why did we even calculate this value? Because maybe I should have started with that. This is basically to use a very smart rate limiting. So instead of saying that you can send X requests per minute, because we already discussed that it's not going to work in case of GraphQL, because each query can have a very different cost from each other. Because one can fetch only a book with title, and the other can fetch books, authors, reviews, and some other stuff. So that's why we should actually calculate the cost of each query and say that each client is supposed to send over the minute queries that are not going to exceed in total something over, let's say, 1,000. The value is, of course, subjective to the way you're going to do the calculation and to the resources you want to allocate to that. And maybe as the last thing, this is something for like an extreme measure. If you want to be 100% sure that you're not going to get any kind of malicious query in your GraphQL server, at least when it comes to the things that we discussed, you can use something like persistent queries. But if you enforce that, you're going to get rid of all the benefits of the GraphQL server. So in this case, instead of sending the query, you're actually expecting the client to either send a hash of the query or send the query key. And all the queries that are supported by the web server are supposed to be like pre-allocated and pre-computed, I would say. So client sends a query signature key instead of the actual query, and the server executes only the queries that are defined ahead of time. In other words, clients cannot run arbitrary, untrusted queries, but this is like a discussion between the security and usability. So we decided to implement a GraphQL server to have all this flexibility so clients can actually define different kind of queries to fetch different data, sometimes fetch something, sometimes not. And if you do this, you're basically getting something that is still using GraphQL language to define things, but you're basically limiting that to a number of static, let's say, endpoints. So we're basically moving towards the REST architecture. But this is the most secure option, because you can say the same way as you could with REST. You can list all the possible queries that you're going to be asked. You're not going to get any surprises, and you're not going to get infinite number of combinations, as we were discussing. Okay, so thanks for being here. If you want to reach me, you can use my work email or my LinkedIn. And let me quickly go over the questions, if we have any. We have. Awesome. Let me take a look at the page. Great. Okay. So first question. I hope you don't mind that I'm not going to show it because it's going to be pretty hard for me to move it there. So I'm going to read it out loud. After 1 year of using GraphQL, would you switch back to REST API? No. The answer is no. I'm actually pretty satisfied with the way you can write GraphQL services. Once you figure out that you have to use data loaders for every relationship to make it performant, and if you remember that you should also check the authorization on every level in order so people cannot get the data that they should not see, it's relatively simple to have it. And I don't have to think about what kind of data I should include in the REST endpoint response, because I'm describing a graph. So actually clients are going to be responsible for fetching the data they need. And whenever I was supposed to write REST endpoints, I always had to think about whether I should include author where returning books. And if I decided to include the author, whether I should include some other things from the author. And it's always like a discussion when I should Because I can always return too much data or too less data. I hope that answers the question. Why would you use and where GraphQL? That's a perfect question. So, of course, you can use it because you like it. I used that motivation in the past. But I would say that this is especially useful for things like Facebook did, because actually Facebook invented GraphQL in order to solve their problems. And when you take a look at Facebook, it's like a big graph of things. Because friends have friends, and friends have messages, friends have groups, groups have friends and other stuff. So basically all those things are connected. So when you have a data like this, it's very useful to have GraphQL. If you don't have a lot of relationships and a lot of things, you probably are not going to get the benefits of GraphQL, and the rest is going to be just fine with you. But whenever you have something like that, you're going to get the extra benefits. And the other example that comes to my mind right now is when you have many different clients with different needs. So for example, you have like a mobile app, a web app, a second web app, and maybe some device, something embedded, and everything is needing a different set of data. You might have heard about the pattern that is called backend for frontend, and this was used to resolve those kind of issues. So each frontend was supposed to use a different backend that was having like a dedicated REST queries for them. And in case of GraphQL, you can use a single API, and the clients are going to decide what kind of fields are going to be fetched. Okay. So third question, do you start a project with REST and then switch to GraphQL, assuming you don't know the exact requirements of the project, or always start with GraphQL? Personally, I would say that it's actually easier to define a GraphQL server, assuming that you have some experience with that. Because you don't have to think about all the REST endpoints that you have to declare, because you're basically trying to expose everything you have in your database in a secure manner. I would say it's easier to do the other way around. So once you have a working GraphQL server, it's actually quite easy to generate a REST web server based on that. Because what you have to do, you basically have to translate the REST endpoint to a GraphQL query and return whatever the GraphQL server returned to you. Okay, how is Smart Root Resolver different from data loaders? Okay, that's a very good question. So data loaders work very close to the source. They work locally. So once you get how it should be written, it's relatively easy to apply that in every place in your code. So it's gonna produce a performant query, even if you do some nested crazy things. When you do a smart resolver thing, you have to start from the top. So either you're gonna use some dedicated library that supports that, like this Django Graphene Optimizer, because if you're gonna do it by hand, you have to remember about like doing the lookup and introspection of the query every time you get it, and somehow pass it later. And it's not gonna work that well if some of your resolvers are not using the same database. Because we work here with the assumption that both books and authors are gonna live within the same database, so we can do like this joins, select in strategies and other stuff. But actually when you have these independent resolvers for each field, the given field can be fetched over the internet from some other web service or whatever. So in this case, data loaders are gonna work still in the same way. And if your external service that you're using to fetch those data supports batch requests, you're gonna do just fine. And it's gonna be, I think, harder to implement that on the Smart Root Resolver. So to sum it up, I would say that even though data loaders have some magic in them, I mean, they're not so obvious to understand, they're actually easier to maintain over the long term. How GraphQL databases make GraphQL issues described by here easier? I would say a lot. If you have a proper graph database, you can basically transform the GraphQL query into the given graph database query and fetch the data in a very performant way. Once again, it assumes that all the data is available in a single graph database. But if you do that, yes, it's going to be relatively simple. And if you want to take a look at the example and how things are actually easier when you have some kind of support for like graph database, take a look at the project that is called, oh my god, kill me, I forgot about that. Okay, I'm gonna check it right after the call. I'm gonna tell you if you're interested, so please stay here. Basically, there's a project that is working as a big external extension to Postgres database, and it's allowing you to query the Postgres database as a graph database. And they already do have an example how to write a strawberry server using their database, using their product, because it's not a separate database, it's using Postgres under the hood.
Is this HDB?
Yes, it's HDB, thank you, man. Yes, it's called HDB. I don't want to go into details whether that's the best idea ever or the worst idea ever when it comes to applying something like that to Postgres, but it's definitely an interesting approach. So if you want to take a look at that, feel free to do so, because they already have an example of the strawberry. Okay, are these clear data transfer benefits of it? It adds complexity, obviously, that maybe it's just not worth for 99.9% of projects. True, I would say that you're not gonna get a lot of benefits when it comes to network transfer, mostly because network transfer is expensive on cloud, but it's not gonna be as expensive when we are still talking about requests. It's gonna get expensive when we're gonna transfer video files. But it's not gonna get so expensive when you like cut the response payload by half, because it's still like a matter of kilobytes. And because of the average internet speed, you're also not gonna see like a lot of differences here. But I guess it might give you some differences when it comes to server load. Because if your client can ask about a subset of fields instead of getting the whole object, and thanks to that your backend server is not going to execute so many queries, it can be more performant. Assuming that you apply the data loaders properly and it's actually able to use that feature. So for example, if I'm asking only for the books, I should only select the books. If I'm fetching the books and authors, I should have more queries. If I'm fetching books, authors, and reviews, I'm gonna get even more queries. And once again, you're not gonna get benefits because of the smaller bandwidth. You're gonna get benefits because in case of REST web services, when you want to get, let's say, books, authors, and reviews, it's quite possible that you're gonna need a couple of separate queries to fetch that data. So we might assume that when you ask for books, you're gonna get authors, right? But usually reviews are gonna be fetched using a separate query. So in this case, you're gonna introduce more queries, and in case of GraphQL, you can send only a single one. So that can be faster because you're not gonna spam the server with so many AJAX requests or basically any kind of request when you talk about the mobile app. Okay, is there a nested pagination? Yes, there is. I think it was visible on one of the slides. Let me try to get back to it.
You're talking about the first and last parameters?
I mean, first and last are mutually exclusive because yes. And what I wanted to show you, let me try to quickly turn on the keynote and find the right example. Okay, so I think we can use this one. So here you can see that we've got pagination applied on both books and reviews. So I think this is what you would call a nested pagination. So as you can see, we can fetch 5 books, and for each book, we're gonna fetch 3 reviews. And the thing that you said about last and first, so those are like mutually exclusive parameters. So you either use first and after in order to move forward, or you use last and before if you want to move backwards. Ideally, you would like to implement both of them, but it's not required. You can only implement first and after if you don't want to go and implement the specification, and that's okay, and it is actually allowed in the spec. Is the cost of the query calculated automatically? What happens when the cost exceeds the limit? So bad news, it is not calculated automatically. You usually have to do it yourself. There are some libraries that support that. If anybody is using, sorry, I have to say that word. If anybody is using JavaScript for server-side development, there is some great support for calculating the costs. When it comes to Python, there are some libraries, but I haven't used any of them, so unfortunately I cannot really help you. I would say the most interesting approach to deal with that would be to actually use GraphQL Federation Gateway, for example, Apollo router, and apply some cost calculation there based on the directives. And the last question, because I think we're actually over the time, is there a next speaker here? Okay, so isn't calculating cost super expensive? Seems like a drawback when compared to REST. Yes, it's additional complexity, but I would say that, okay, let's put it that way. GraphQL servers are actually more expensive in terms of computing compared to REST web services. Because calling each resolver and doing that recursively is actually pretty expensive. But this is what you have to pay for the flexibility. Okay, thank you so much.